All right, folks, we're going to pick up from our last segment on multivariate regression modeling in Excel, where we covered adding both numeric and categorical dummy variables, if you will, for categorical variables, where we had to code them numerically as a right-hand side variable in a regression model. In the last segment, we concluded our analysis by comparing the three models we have built. Model one had just a single choice, a single predictor variable on the right-hand side. That was ad spending. Model two included both ad spending and impressions. And in model three, we included ad spending, impressions, and promotions. That being said, we saw that in model two, impressions was not statistically significant. And in model three, impressions and promotions both had statistically insignificant effects when we also controlled for the amount of ad spending on the right-hand side. So what we're going to do to wrap things up is we're going to build a fourth model where we're going to purge the insignificant variables we had for the previous two. And then we're going to go ahead and also show how to create a dummy variable column from a categorical variable that maybe has more than two categories. So let's jump back to our data set here. In fact, before we do that, maybe I should zoom in on this summary page here. Let's just do that, zoom to 120. And we'll add model 4's summary information here momentarily. You might notice that looks a little bit different. I added a few things and cleaned it up relative to the last segment. But we're now going to go back to the data set. We're going to clear out promo and impressions. Recall those were not statistically significant. And we don't need to label these anymore. We know ad spend is an X variable. Sales is the Y variable. And let's go ahead now and think about creating a new dummy variable based off of the day of the week categorical information. Okay. How many different levels are there? How many different categories are there in the day variable? Well, there's 7 days in a week. So we should notice every 7 days, the days are kind of repeating. But even if the days were out of order, even if we had some unbalanced data where maybe most of the days sampled were Mondays, there were very few Saturdays, the day variable would still be a categorical variable. And we may be interested in, for example, in the effect that a particular day of the week has on sales. And marketing people know that Saturday is a pretty big day for kind of checking these types of effects in a time series environment. And again, this is time series data, but with that being said, if the day was some other arbitrary category, you could still conduct cross-sectional analysis with this type of data set if you're careful. So just to be clear, I'm not doing any sort of rigorous time series analysis with this data set, mainly cross-sectional modeling, so no auto-regressive processes or moving averages or ARIMA or anything like that. But let's go ahead and add a column called Saturday. And what we're going to do here is we're going to use a logical statement, an if statement, to basically code this column as zeros and ones by referencing column B and checking, is the value in column B equal to Saturday? If it is, we want it to be a 1. If it's not, we want it to be a 0. So what I'm going to do here is I'm going to start off by creating a formula with the equal sign. And then I'm going to invoke the if function, equals if. And then inside the if function, it asks you first for a logical test. And that logical test is going to be, is the day of the week in column B, Monday, equal to the value at the top of column L, which is Saturday. And I'm going to go inside the formula here. This is very subtle. I'm going to put a $ in front of and after the L, so that when I click and drag that formula down, what Excel will do as I click and drag down, it will start referencing these values as we go down, but it will stay locked in comparing them to this cell here. Okay, so the B cells will drag down, but the L column will still be comparing every one of the B cells to Saturday. Is it Saturday or not? And that's what we want to be able to do here. All right. Now, the other thing I have to tell it, after the logical test is B2 equal to L1. If the answer is yes, I want it to give the value 1. If true, if no, I want it to use the value 0. And we'll hit enter. And it should make sense that this value is 0 because Monday is not Saturday. So the Monday is coded as a 0. And let's go ahead and click and drag this down to the bottom. And make sure we are getting results that make sense. Notice that Saturday, 12/15/2018 is correctly coded as a 1. And every 7th day, I'm seeing a 1 in this data set, which should make sense. Okay, so hopefully you are comfortable that we've coded this correctly here. We have a dummy variable now in column L. And the way to interpret that, if it's a 0, it's not a Saturday. If it is a 1, it is a Saturday. And now we'll build a model. We'll call it model 4 by, again, going to the data tab, invoking that data analysis button here. And using that regression tool. And all we're going to do now is we're going to adjust our Y range. We still want to predict sales as the Y variable. And our X input range now is going to include just the ad spend and the Saturday effect. So we have one dummy variable, which is really categorical. That is the Saturday or not variable. And we have one numeric variable, which is our ad spend variable, which we saw was robust to the inclusion of either impressions or promo. The effect didn't really change. It was always significant. Impressions and promo were not, so we removed them. And we've now added a different variable for consideration. And I'm labeling this model 4. This will be our final model that has both a dummy variable, categorical variable, Saturday or not, as well as the numeric ad spend variable, both being used to predict sales. Okay, so let's go ahead, zoom in here. Let's spread things out. Let's auto fit that column width. Okay, so this is the last model we will consider in this series of segments. And the first thing we want to, again, look at always is we want the model coefficients. And I use those coefficients. I can write down the equation, right? Sales equals 12,872. That's the intercept plus the Saturday variable, which is either 0 or 1, times the coefficient minus 1731, point, etc., plus the ad spend variable times 18.75. Okay, that would be the equation, right? That gives me the equation of the regression line, which is useful if you want to plug in counterfactual observations and make counterfactual predictions. Note that the ad spend variables effect is still roughly the same as it was in Model 3, in Model 2, and in Model 1 from the prior segment, still roughly around 19 units of sales for an added unit of ad spend, and it's positive. Okay, again, the T statistic is much larger than 2, the p-value is smaller than 5%, and the lower and upper bounds of the confidence interval are tight, both positive, they're not changing sign. So ad spend here, still significant, still a robust driver across all 4 models. Okay, if you look at the Saturday effects, okay, how do we interpret that? Well, if Saturday is a 0, okay, then it's not Saturday. But if Saturday goes from 0 to 1, okay, then we can see that while ad spend predicted a positive effect on sales, every time a Saturday rolls around, what's happening to sales? Sales are actually going down by roughly 1,731 units. Okay, so sales Saturday has a negative effect on sales. Is it significant? Well, the T statistic is bigger than 2 in magnitude, but even better, the p-value is smaller than 5%. They also note the lower bound on the confidence interval is negative, as is the upper. It does not change like it did in the 2 cases where we had insignificant X variables, right? That was promo and impressions were individually significant. Okay, so now we have a model where every one of our parameters is significant. The intercept significant, the Saturday variable is significant. That's a categorical dummy variable that we've included. And the ad spend numeric variable is significant. What about the overall model performance? Well, we can see here the R squared explains roughly 55% of the variation in sales coming from using the information in the Saturday variable and the ad spend variable. And the standard error is still roughly 5,000 units, just a little bit under that, 4,900. Okay, and we want to be able to kind of compare the last model we've built here, model 4, to the other models that we've built. So let me go down to our model comparison tab here. And let's go ahead. We'll make some room for model 4. And I will just pull the information directly from model 4, and we will drag that down, and we will drag it across. Let's auto fit the column width. The X variables we included, we had ad spend, but we got rid of impressions and promo, which were not significant. We added a new variable, a transform variable, which wasn't even in the raw data. I had to transform a variable here to make that Saturday variable. And notice, if we compare all of, let's first start with the R squareds, okay, which is not really a good idea, but if we only care about fitting the data, not predicting well, they're not the same thing. I want to be clear about that. Okay? And these segments are really more concerned with fitting than we are predicting. But you'll notice the model that fits the data the best in terms of R squared is actually model 4. Okay, from models 1 to 2 to 3, the R squared was going up, but that's just because we kept adding more and more variables, right? From 0.5386 to 0.5389 to 0.5397. It was going higher and higher and higher. And that we expected to happen. As we added more variables, the R squared will never go down. Okay, but even though we took some away, when we go to model 4, still the R squared goes up even more. So model 4 does fit the data the best. Okay, but I'm also going to argue that model 4 does a pretty good job of predicting fairly well here, as noted by the residual standard error. What is the average forecast error of model 4? It is only 4,909 units of sales, roughly 4,910-ish units. Okay, notice that is smaller than model 3 standard error, model 2s, or model 1s. If we look at the adjusted R squared, the adjusted R squared for model 4 is also the highest. It is also the highest. So by really all of these metrics here, adjusted R squared, standard error, it looks like model 4 is maybe the best model for us to proceed with at this point. There are many more details with respect to model selection that are not covered in this segment. I want to be very clear about that. We've been concerned with model fit, not so much with how well we predict out of sample. So again, if you're interested in that, check out some of the content on predictive analytics, specifically the difference between training and testing models. And with that, I will bid you farewell. Have a good one.